Hey, what's up, guys? Chung here again. So today I want to talk about this lead code problem number 679, 24 game. It's a hard problem. Yeah, I think it is a hard problem. So basically you're given only four cards and each card contain a number from 1 to 9, okay? And you need to judge whether they could operate it. Basically, if those you can combine make a formula, right, for those four cards that the result equals to 24. And you can either use multiply, divide, plus, subtract, or the parentheses, right? Basically, you can just concatenate any of the two, any of the two numbers here, right? And okay, so how should we approach this problem, right? I mean, notice that here, notice that here we have a like this left and right parentheses. So what does that mean? That means we can just use any sequence, right? So basically we can calculate any numbers, any two numbers first, and we don't have to worry about the sequence here because we have this left and right parentheses. Basically, we can group any two numbers here, right? And we can do any of these four operations here. So So then this problem will be converted to like a DFS search or backtracking, right? Basically every time, right? Every time we uh for each of these current cards here, right? We pick any of the two numbers. Basically we try all the combinations of the current cards, right? And then for each combinations, we basically let's say for example if we have this, let me increase this size a little bit. So for example, this is 4, 1, and 8, and 7, right? Basically, we try each of the combinations, okay? And for each of the combinations, when I say combination, I mean I pick any of the two cards for this current list here. And for each of the two cards, I will also calculate all the all the possible results between those two cards. That will be multiply, divide, plus, and minus, right? And then among all those, for each of the possible results, right? I'll get that result and then I will just append the remaining cards to that result and I will pass it to the next level of traverse of the to the next level of the calculation. And I do it until recursively until there's only one card left in the current list. And then I just compare when there's only one card left. That's our final result, right? And then I just compare that final card result with this 24. If it's 24, then okay, we find a solution. Otherwise, false, right? So for example here, so we have basically we're gonna have like a DFS method here, right? DFS, and this is gonna be our current cards, right? So let's say for example, if we pick the 4 and 1 at the first time, right? Then we're gonna have like try to get all the possible values between 4 and 1. So for 4 and 1, it's gonna be 4 plus 1. That's 1, right? And then 4 minus 1, right? So for the plus, there's only one value because 1 plus 4 and 4 plus 1, they have the same value. But for the minors, we're gonna have two, 4 minus 1 and 1 minus 4, right? 4 times 1 is the same, right? And for the division, we also have two values, right? 4 divided by 1 and 1 divided by 4, right? Basically, at most we will have six. At most we'll have six possible values between those two values, right? Between those two numbers. And then for each of these numbers there, we will basically this is going to be 5, right? 3 with negative 3, 4, 4, 0.5. For each of these values, we're gonna append the rest of the 8, 7 here, right? 8, 7, 8, 7, and so on and so forth. For each of those, we'll make this one as a new card and then pass into the same DFS. Okay, right? With this one, with this card, the updated cards. We continue doing everything until we reach there's only one card left, right? Then we compare if that card left is the 24. But remember here, since we'll be having like this division here, right? So for example, this one, see, 2 divided by 3 will have like 0.6666667 indefinitely, right? And then in the end, our final cards, the answer may not be exactly equal to 24.000, right? So since we have this division here, we when we compare with 24, we're gonna have like a buffer. Basically, we compare if the difference between 24 is within the range of 0.0001, right? If that's the case, then we're simply assuming, okay, it's almost 24, and we treat it as the 24. Mm. Yeah, I think basically that's the basic idea here. So let's go to the codings now. So and like I said, I'm gonna have like a DFS here. Actually, for the since we're using the same numbers here, we can just use the keep calling the function itself. We don't have to define a new DFS method here, right? So let's just do a I'll just call this function by itself. So uh, like I said, so we're gonna have like numbers here, right? And then we check if the number is 1, right? And then we see if the nums 0, right? Since there's only one left here, my 24. Okay, so it could be bigger or smaller, so that's why we need to do a absolute value. So less than 0.001, right? Then we said, okay, this is true, right? Else return false, right? Okay, so now if it's not 1, then we have to do the similar thing, right? We have to do a we have to pick up. We have basically we need to find all the combinations, right? Of the two numbers. So we do I in range n, right? To get all the combinations, we do a nested for loop j in range I plus 1 to n. Okay. Now we have a card 1 and card 2. Card 1 equals to the nums mm, I, right? And card 2 equals to nums j. So then what's going to be the possible results for this, right? Like I said, possible result equals to the C1 plus C2, okay? C1 minus C2, C2 minus C1, and then C1 multiplied by C2, right? So the reason I don't do a division here is because either C1 or C2 could be 0, and if that's the case, we'll have like a divided by 0 exception. That's why I simply do a simple check here. If C1 is not empty, right, and then it's possible to a possible result, and then I add the division result here, append C2 divided by C1, okay? And same thing, if C2 is not empty, do a possible result, append C1 divided by C2, okay? So now we have all the possible results we have in this of this current two cards, right? And then for each of the possible results here, right? We will pass that, and we'll pass this result plus the remaining cards, other than these two cards, to the next level of the DFS traverse. Okay, so and okay, I'm gonna do this. Okay, so here, I'm using I'm using like a new arrays here basically, and let's see, and or we can or we can use a backtracking methods here, right? Or we can create a new arrays here. Let's try to use a backtracking here. So basically, what do? We remove it. We remove those two i's from the basically first we'll be removing those two numbers from this numbers, right? We do a nums dot remove, right? Remove c1 and nums remove c2, okay? And then we do a nums dot append, right? We append the current value, right? And then mm, we pass the updated number to a DFS. It's basically if the DFS and updated numbers, right? If the updated number DFS is true, then we return true, right? If it's false, we continue, all right? But since we are using like this is the we're gonna try each of the possibilities here for each of the uh, okay. So I think here we can uh, move this thing out, right? Because this is for each of for all the possible numbers here, we're going to remove the C1, C2 anyway, so that we can do this at the beginning of each for loop. And here we just need to remove these numbers in the end, basically pop. Okay, because for each of the possible v numbers here, once we process this number here, we finish doing this, for the next for loop, we need to pop the previously result, right? Because we want to try all the possible numbers. And since we're using the same numbers here, that's why we need to pop it, right? And then, okay, so, and then, okay, once this is done, we're gonna need to add append C2 and C1. The sequence doesn't really matter. C1, C2. Okay. Because the next combinations, we're gonna have like different C1, C2, and we want for each of the loop here, we want to make sure our the nums is a fresh start for each of the loop here, right? And then in the end, if there's nothing there, we should simply return false. If none of those is true, and if this is not true, we simply return false in the end. And okay, I think let's try to run it. Yeah, what I mean. Self dots. Okay, right. Mm. Let's see. I think here, yeah, don't have a pop here, missing a parenthesis here. Okay, so this one accepted. Let's try to submit it. Mm, false. I see. Uh, hmm. Yeah, I think I finally figured out what did I do wrong here, because you guys see I remove these two numbers here, right? And then I append them into the end. Although the number are the same, but since we're doing the looping here, right? We're looping it based on the index here. Once I remove them from the list, right? Then when I try to add them back, the sequence will be different, right? So I believe in this case, a, a better way will be every time, instead of like doing the remove it from the numbers and then try to add them back while keeping the same sequence, we should create a new integer. Sorry, we should create a new array to store those values here. So basically, every time, right, when we have a new values here, we create a next card, right? Next cards will be the first one will be always the v, right? And then here we'll be simply doing the if uh, mm, and then we'll need to append the rest of the yeah, basically here we need to append the rest of the numbers into this next card, right? So we simply do another if check. We do another like a loop here, k in range n here, right? If k is not is not in I and j, right? Because we will I need to exclude those two numbers, right? And then for next card dot append to nums k, all right? And then here, so and then I can simply remove everything here. I can remove the all those backtracking issues here. So I simply every time I simply create a new element, right? And then first we append this thing, and next we append the rest, which is not these two numbers, right? And then we pass this next round cards into the function itself, right? And then let's try to run it. Oops. Okay, not in. All right, let's try to submit it. Yeah, so this time it works. It passed. Basically, uh, the main idea here is like do a real recap here, a quick recap here. And the main idea here is since we have this left and right parentheses, we can basically simply pick any two numbers as our current operator, and then we get and then for those two numbers, we get all the possible results from those two numbers, and then for each of the possible numbers, will be trying that possible numbers with the remaining numbers, and we pass it into this DFS method itself until when we reach the end, we compare the final result, right? So this is this is like the graph sortings, right? Backtracking or DFS, whatever you want to call it. And in the end, basically we try all the possible combinations for the two cards first, and then for each two cards combination, we try all the possible values, and we keep doing it until we reach the end. Cool guys, I think that's pretty much it is I want to talk about for this problem, and I hope you guys uh, enjoyed the video. Thank you so much for watching the video, and see you guys soon. Bye bye.